In this course, you will improve your Python skills by creating a snake game using the Pygame library. This course was developed by Deval Patel from the popular Code Basics YouTube channel.
We will be building famous snake and apple game using Python and Pygame module in this Python project series. As a prerequisite, all you need to know is basic Python. Anyone can do it. I am going to simplify a lot of concepts, and this will be multiple video series, so we'll go over step by step on different Pygame concepts and we'll build a complete game. So you're not only learning Pygame, but you're also learning how to build a complete end-to-end project in Python. In the end, I also have an exercise for you to work on, so you can use the knowledge that you learn in these videos and then you can customize the game as part of that exercise, and I have the solution as well. So this will be not just you're just watching a video, it will be interactive learning, so it will be very, very useful. Let's first talk about the things that you need to install. Very first thing is obvious, Python installation. You need to have Python installed on your computer. Then you need to install a Pygame module, which you can do it by running pip install Pygame. I already have it installed, so that's why it's showing this, but you need to run this step. And I use PyCharm community editor. You can just Google PyCharm community, download it. If you like using VS Code, that's okay too. I went ahead and created this snake_game directory to store my code. So you just go ahead, create some directory, and then open that directory in PyCharm by going to File, Open. So when I did this, it was showing me this thing. Now in this directory, I have already put some useful things. So first you need main.py. So main.py is the main file. It is empty right now. I also have resources folder, which will have different resources that we will need for our project. For example, it has an image of an apple, some background, some block image and all that. Okay, you can download all this code by looking at the code link in the video description below. Here, our first objective is to write the first program which uses Pygame, and it draws a simple game window. Okay, so at the end of this session, all you're getting is a simple Pygame window with some background. So let me just close this and go into Zen mode. So PyCharm has this nice feature called Enter Zen mode, where you can have a full screen experience. Okay, so here I will say import Pygame. I'll make it a little bigger, control scroll. And then I always use if underscore name is equal to underscore main. This is the main routine in Python, okay? And in this routine, what we're going to do is initiate the pygame.init. So let's look at the Pygame documentation, by the way. So if you look at Pygame documentation here, you can go to the Pygame website, look at all the tutorials and kind of explore it. But in this tutorial, whenever you're using Pygame, you have to use this .init method. It will kind of initialize that whole module, okay? And once you have that, next thing will be creating a surface. So what is surface? So you will say pygame.display.setMode. Okay. So what is set mode? So let's look at the documentation. So Pygame set mode. Generally I Google it, okay? And when you Google it, you can directly go to that. So here you are saying set mode. So set mode is initializing your game window. This is the very basic step that you have to do in all Pygame program. And see, the first argument is the size of the window. How big is your window size? Okay, so I will say my window size is maybe what, 500 by 500. This is like 500 by 500 pixel. Okay, and you can now say that uh, so let's just maybe run this program and see what happens. See, window came and it disappeared because the program finished. So I will just maybe put some timer so that you can at least see, I will put a timer for 5 seconds so you at least see what's going on. So, okay, my window unfortunately came in a different screen actually. Yeah. See, you get this window 500 by 500. If you have 1000, you will get a bigger window. See? So that's what this is doing. Now the window background is black. I want to change it. Okay, so you will say surface dot fill. So this fill function will fill the background with some color. Now any color is RGB. So red, green, blue. And these colors have values from 0 to 255. So if you want white color, you will say like 255 three times. See, this did not work because whenever you update your surface, you have to say uh, pygame dot display dot either update or flip. So flip is saying that whatever code you have written here, you are just you're just updating your screen with it. So you say Control F5. Now your screen is white. Okay. If you're not sure about which color you want to pick up, not no RGB values, so then you can do RGB color picker. So the Google has RGB color picker, so you can decide your color. Okay, which color do you want? Maybe I want this color as a background. What is RGB? 92, 25, 84. You put that here and say you get this color. So getting that color is not a big deal. So I'm just going to use some color. You can use a different color, up to you. Okay. All right. So now your window is set. Next thing I want to do is see, I had to use timer, which is something I don't like. I want to do something where the window stays, and when I hit escape or cancel, then only window disappears. So I'm going to remove this sleep statement. So how do you do that? So in any UI application, you have a thing called event loop. Event loop is waiting for the user input. When you're working on any screen, it is waiting for mouse input or keyboard input. So you have to run that event loop. Event loop is fundamental to any UI programming. Doesn't matter Pygame. Any UI you take, you need to have an event loop. An event loop will be something like, it's a while loop. So you will say, okay, running is false, or maybe running is true actually. So running is true, and while running, do something. So now see, this is an infinite loop. We need to exit it somewhere, right? But the fundamentals of UI programming is you are running this infinite loop, but on certain keystrokes, such as if you hit a cancel or escape, you want to exit your game. So how do you do that? Well, Pygame has this thing called event. So pygame.event.get. So for event in pygame.event.get, do something. So what is this? Well, this will give you all the keyboard, mouse, all kind of events. Okay, and you can read the documentation online. But these events will have types. So if event dot type is equal to what? For that, I need to import certain locals. So I will say import pygame dot locals from, I will just do this, import star. So this is going to import certain global variables which will be useful to us, such as key down. See, this key down, this one came from this. Okay, so if you want to read more about it, you can just say Pygame locals, and that will tell you all the locals, right? So event, so for event you will have different locals and so on. See, for event, these are the events, right? So key down is something we use. There is another event called quit, which will be called when you hit the cancel window. So I will say, okay, if event.type is key down, then do something. If event.type is equal to quit, okay, then okay, so if user clicks on cancel, what do you want to do? Well, you just set your running variable to false. You might have read about while loop before, or if you have followed my Python tutorials, you know about while loop. While loop is like it goes in iteration until this condition is true. So running is true all the time, except when we have a quit event. Okay, so let's try this. So quit event is generated when you click on cancel. See, now your program exited. Otherwise that window will not exit. Okay, also let's say I want to quit when I hit escape key. So you can say if event.key is equal to escape, then also running is false. So when I run it now and say I'm not using mouse, I'm hitting escape key and my program exited. Okay, so this understanding of this whole event loop in Pygame is very essential, and it will be useful when you're doing UI programming with any language, any framework. All right, so far it is looking good. Now the next step, I have some reference content here so that I can do my videos properly. So the next thing I want to do is I want to draw a block. Okay, so that block you saw here. So I have this block here. So this image I want to just draw on my screen somewhere. All right. So how do you do that? Well, for that, you need to load that image. And the way you load that image is by doing this. So Pygame has this image module. You can just say load and resources block.image and dot convert. This is a method of loading the image. And once you have the image in this block variable, you can see, let's look at load documentation. See, this is the load documentation, okay? And block, you can paint on a surface. So your background screen is this surface. So you will say surface, surface is your background, your main window. On that, if you want to draw a block, so for that there is a function called blit. So this blit function is nothing but draw this image. And what do you want to draw? Well, block. Where do you want to draw? These are the dimensions. So maybe 100. You see 100 is drawing here. If you do 0 0, this is x and y. So if you do 0 0, it will draw at the very left. So this is x and y. Okay, so I will just assign some variable for the dimension. So I will say block x is 100, let's say, and block y is also 100. Okay, and then block x, block y. All right, now Next thing I want to do is I want to move this block. Okay, so when I move this block using my maybe key, like one of the common things in any game is using the up, down, left, right keys. Okay, when I press those keys, I want to move the block around. So how do I do that? Well, first let me write a function which draws this block. So I'm going to write a Python function which is drawing the block. Okay, so it's the same code. See this code, I have just put it in a function. So I put 1, 2, and 3, these 3 lines into a function. So when I call that function, it will just draw a block. So now how do I move that block? All right, so let's think about that. So here we are getting these events, right? So if event.key is equal to, let's say, up. See, when you press up key, what you're doing is your block is at a position X. Okay, so let me just draw it so that you understand. So when you are, let's say this is your screen. Okay, on this screen you have a block. So this is your block, and block is at the position X comma Y. So it's a coordinate system, X and Y. Okay, so let's say this X is 100 right now. So X is 100 and Y is also 100. Okay, so when you move up key, the X remains same, but you're changing your Y. Your Y is 100 and now you're moving it up. So maybe you're changing it by some amount. When you move it down, again, you're changing Y. But when you move this block, see, when you have this block and when you move it like this, your X remains same because X is this, but your Y remains same, but your X will change. So see, your Y, so this Y is this axis, okay? And this X is this particular axis. You might have learned about basic coordinate system in your mathematics class. So it is this X. So when you have left and right movement, you are playing with X. Up and down movement, you're playing with Y. So when your key is up, what I want to do is, whatever Y I have, maybe I want to subtract 10 from Y. This is same as doing this. Okay, they both are same. And when you have, let's say, down, you want to increment Y by 10. And if you have, let's say, left, when you press on a left key, you want to update your X actually. And if your event key is this is all probably very easy to understand. You're just changing your coordinate. Now, when you're having up key, you're not changing your X because X remains the same. And when that happens, you are just after changing your coordinate, you are calling draw block function, because draw block needs to draw it. Now let's look at draw block function. So in draw block function, by the way, when you're moving your block up and down, uh, let me comment this line. I'll tell you why that line is needed. Let's first do it without that line. So you're operating block X and Y, and using that, you are drawing that block again. And you have to call this flip method. Otherwise, it will not show you what you have done, right? You can also call update method. Okay, so I'm just calling. There is some minor difference. You can read about that online. So if I do Control F5, now see, When I'm pressing right key, it's moving right. And when I'm pressing down key, it's moving down and then moving left. But the previous block are still there. I don't want those blocks. When I move the blocks should just move. And for that reason, you need this line. So before drawing the block, you are clearing your screen. So when you have this line, now see, you do up, left, right, whatever, and block moves smoothly. So congrats, you have a very first basic Pygame program working for you. You did an awesome job. When I'm teaching you on video tutorials, make sure you have your code editor open and you do coding along with me, because that will give you effective learning. In the next session, we'll continue with this, but in this session, I have only this much. You just build a screen and a block which can move around. All right. So far, our code looks good, but the code is not very readable. So in this session, we are going to make it object-oriented programming. So there is a thing called object-oriented programming, or OOPS. So we are going to make it such that it follows the OOPS principle, which is basically converting this into classes and objects. So let's get started. Here, you see a huge block of code in your main function itself. Usually when you're working on proper Python projects, you don't write so much code in your main entry point. So you would have things like, all right, what if I have a class called game? Okay. And this is how you define class. If you don't know about classes and objects, you can follow my Python video on classes and objects, and you will get an understanding. That's like a prerequisite. Here, this is a constructor. So we'll write constructor. But what if in my main method here, I have only 2 lines of code? And that code will be, you create an object of a game and you just say game.run. Okay. And here, of course, you will have a run function and we'll implement all these functions. But this is my idea. I want to have only 2 lines of code in my main method, and everything else should be classes and objects. All right. So let's start moving all of this code into your classes. So the Pygame init, of course, this will go into your game initialization. Then the next thing you have is a surface. So this surface will also go into your game initialization, and I will make this surface a class member. And when you do self dot something, you're making that a class member so that later on the surface is available here as well. Okay, so that's the idea. All right, so we move that. Okay, we have block, which we will look into little later. But let's see if there is anything else. Nope, that's it. All right, so far game looks good. Now the block is something we are building to build our snake ultimately. So then how about we build a class called snake? Okay, and that class, this class will have that block object. So let me move all this here. So again, I will say self.block, and then self.x is 100, self.y is 100. All right. So this way I get rid of that code. So see, you now kind of get a feel of this process where you have written some experimental code, and when it works, you want to convert it into a object oriented code, and this is how you do it. All right, now when you see, this is like drawing the block. So I want to draw the block So in my snake method, maybe I can add draw function, So when you say snake, snake.draw, it will just draw that snake. So right now a snake is just one block. Okay. Here I need a parent surface, but I don't have that. So generally when you're doing class programming, you want to pass that surface as an argument in this function, or the other option you have is you store it as a class member. So I'm just going to call that surface a parent screen, and I will store it in a new class member called parent screen. Okay. And when I draw it, I will say self dot parent screen dot blit. And this block has to be self dot block, and this x and y has to be self dot x, self dot y. All right. Okay. So now, this game, see, this game is kind of the main object, and game is having a snake inside it. So you have a game has a snake. So for that reason, I will create a snake inside my game class. So I created a snake inside my game class. Now snake constructor expects parent screen. So what is my parent screen? Self.surface. Okay. And once that is done, I want to draw the snake. All right. So this looks good so far. So by the way, when you draw this, you're drawing this. So we are kind of replacing this function. So that draw function is exactly this draw. So there were two more things that we wanted to do, which is fill, and see, this line will come in the middle, okay? And this will be self.surface.fill, and this will be pygame.display. So when you have snake and when you say snake.draw, it will draw the snake or a block on the surface. So now we remove this function as well. Okay, what is left now? Okay, a main event loop is left. So this main event loop, I will copy this in a run function. Okay, because like run function is kind of the main function. So we are running the event. Let's look at it. Okay, here I don't have access of block X and draw block, etc. Right? So what do we do? But we have access of snake object. So snake. All right. So let's do this. So when you do left click, you want to move the snake to left. So what if we have a function called move left, so that I don't have to worry about all this? When you say move left, it should move left. When you press right key, it should move right. Don't you think that this will be amazing? It will make code so much readable. So move right. I'm just typing these methods. They don't exist, but I'm going to write them. This is how you do object-oriented programming. Move down. Okay. So I need to write all these methods in my snake class now. So let's write that method. So move left. Okay, what do you do when you move left? We saw in a previous session, moving left means you are just changing a position of X because your Y is same. So I will just do self dot X minus 10. Subtract 10 pixels from your X so that your block moves on the left hand side. Once it is subtracted, you want to draw it. And for drawing, there is a method. So you can see your code is becoming more readable. It kind of makes sense in your brain, right? moving left is subtracting by 10 and then drawing it. Previously, code was little cryptic. And similarly, uh, you can maybe implement the rest of the methods. See, move right, move up and down. Okay, so it's very easy to understand now. So when you read your code, see, you're starting your Python program. First, you're creating game says run. Okay, what does run do? Run is running your event loop. In the event loop, you are having snake, you're moving left and right. So code is more readable now. And when you right click and run this, okay, snake object doesn't have an attribute self.surface. Yeah, it doesn't have self.surface. It has self.parent screen actually. So I'm pressing left and right key and the block is moving. I did not make any functionality change, but in this session, we did an amazing thing, which is converted a programming to object-oriented programming. This is needed if you want to become a good programmer. A good programmer can write program in object-oriented programming method, and the code is readable, maintainable. You know, when you work for big companies, the code bases are very big. So when new person joins, already there are million lines. So if code is readable, like see right now code is more readable, then it helps. So OOPS or object oriented programming concepts makes you a better programmer. That's why I think that this session is very important. So I hope you all learned all these lessons. Till now, we are moving this block manually using left and right keys. In this session, I want to move this block automatically. You might have seen games where blocks are falling, planes are flying. You don't do anything and they keep on moving. So I will do the same thing with this block so that if I'm not touching any key and if it's going down, it keeps on going down. When I touch a right key, let's say, it will just change the direction, but it will just keep on moving on its own. So for that, what I need to do here is introduce a timer. See, in this while loop, this code is handling all key events, but outside this block, like here, I need to maybe put a timer. So here I will put some timer and on that event. So let's say I have some method called self dot so if I have a method called self dot snake dot walk, so snake I have, right? So just hypothetically think, we don't have this method, but just hypothetically think that on this method, snake walks on its own without you pressing a key. Now this rule loop is running very fast. So if you do this, snake will move really fast. So you need to introduce some delay, and you can use time module for that. So we'll introduce some sleep time. So here we'll say time.sleep. Let's say 0.2 second. So every 0.2 second, it moves on its own. 0.2 second moves, 0.2 second moves. And in this walk function, we need to implement here. So let me just implement walk function here. So walk. Okay, what do we do in walk? Well, of course, in walk function now you'll be drawing the snake, and based on the direction, based on the current direction, at given point of time, snake could be moving left, right, top, bottom. So based on the direction, you need to increase the X and Y coordinates. Okay. So we need to have this direction parameter, which I'll add here. So self dot direction. Let's say initially you're making a direction up or down. It could be anything. I'm just randomly selecting. And based on that direction, so let me do this. So if self dot direction is up. So if it is up, what do you do? Well, we saw previously that if it is up, you only reduce y. See, we are reducing y. And if the direction is, so let me just copy paste just to save some time here. If it is right, of course, you are manipulating only x. If it is up, y, and so on. This is something we already went through when we are looking at this function. And you draw it. So now what will happen is, even if you are not pressed your any key in your while loop based on a direction, snake will keep on moving on its own. Now what happens when you press any key? Let's say if you press left key, you call move left, which is fine. But on this move left, you don't want to change anything. You want to change only the direction. Okay. So I will say move left, my direction is left. If it is move right, my direction is right. Move up, direction up. Move down, direction down. Looks good, I think. Now let me try it. So just to go over it, on while loop, when you call this function, you're just changing a direction. And even if you have not pressed any key, on walk function, based on a direction, you are moving the snake. So say I'm not pressing any key now, you see my hands and block is moving. When I press right key, it just change the direction. Up key, change the direction. Left key, change the direction. All right, looks great. It already looks like a game, don't you think so? In moving blocks games, this is what they do. So congratulations, you just implemented a nice version of a little small stupid game. In the next video or in the next session, we will convert this block into a full-fledged snake. In this session, we will be building a snake out of a block. See, right now there is only one block. It is moving on its own. This is actually a snake with length 1. If I put, let's say, 5, 6 blocks, let's say if I put 6 blocks, then this becomes a snake. So we'll introduce a length parameter in our snake class. And if let's say length is 5, then it will look like this. So instead of 1 block, we have 5 blocks. So the first thing I'm going to do now is enter my Zen mode. You know, I'm doing a meditation, the snake and apple meditation. So here I will introduce a parameter of length, length. So self dot length is equal to length. And now I don't have a 1 x and y, because when you have a snake with size 5, essentially you have 5 x and y. See, 1 x and y is nothing but the left top coordinate of a block. So if you have 5 blocks, you should have 5 x and y. And how do you do that? Well, in Python, this is easy. You can do something like length. Okay. So this will initialize an empty array of size length. If you want to verify it, what I do usually is I go to Python console. So exit the Zen mode. I go to Python console here. And if you do something like, let's say this 5. Oh, this is not working. Okay, I need to give an some value. So let's say if I do 67. See, if I do 5, it's creating an array of 5. If I do 3, it will create an array of 3 elements. So that's exactly I do. This Python console is a useful feature. You can use it. So now I will just initialize it with size 40. So by the way, I will just create a variable called size is equal to 40. And this size is nothing but the size of a block actually. The actual length of the snake is this length. And see, if you look at my block, block.jpg, right? This is the image we are using. If you look at the dimension of it, it is 40 by 40. So that's why I want to put initial position to be, let's say 40, 40. It could be 80, it could be 120. And then I want to just implement my move logic. Now, before I implement my move logic, I need to change the draw function, because draw function is just drawing one x and y. Now we have multiple x and y. So instead of this, I will have a for loop, and I will say, go till the length and do draw x and y basically. Okay. Now initially, I initialized my entire array. Let's say if you have a snake length of 2. So let's do that. So here, when you create your snake, let's say I have a size to be 2. You would ask me, why do you have both the blocks at the same position? Ideally, you should have it at different position, but my move logic will take care of it. It will unwrap my snake, as I move. So how would I change my move logic then? Well, before I do anything, let me just run it just for the sake of it. Oh yeah, it's not working because when you walk, you are changing this x, and this x is an array now. Okay, so we have to implement this walk function. Okay, how does walk work? Well, let's see. So when you have a snake like this, okay, and let's say if I move it in a right direction, I put a right key. What's happening is, let me mark this line. See, this is my head, right? This particular block. When I move it to right, the block will move to right. Okay, so my block move to right. Perfect. The logic for this is what we saw already. If you're moving right, increase x by some amount. Moving up, increase y by some amount. But what do you do with these other blocks? Well, my second block comes at the position of my first block. My third block comes at the position of my second block, and so on. So every block is taking a position of its previous block. Now writing this logic becomes very easy, because here when you're changing a direction, of course, the logic remains same for the first block, which is your head of the snake. Okay, so this remains same, but we have more blocks. So for those blocks, you need to put them at the position of previous block. So how do you do that? Well, you have to run a for loop in a reverse direction. So you start with the last block. So fifth block you put at fourth, fourth you put at 3. And in order to do that, you can just do this. Self.length -1. Okay, go all the way till 0. In a range, by the way, it will not consider 0. So actually you are going till 1. And -1 is a step size. So step size means you are going in a reverse. So this for loop is nothing but going in a reverse direction. You start with 5, 4, 3, 2, and so on. And the current x position will be your previous block's position. Okay, and you do the same thing with your y. All right, let's see. See, now actually it's a snake with 2 blocks, but see, the distance between the blocks is very minimal. It's like 10 pixel. So I need to make it size, which is a 40, so that the size of block is 40. So you want to keep them 40 pixel apart. So yes, size. Great. See, I move it up, left, down. My screen now is a little smaller, so I want to increase the size here to, let's say, 1800, and also the just increasing a timer so that it's not moving very fast. See? So this is how the snake with length 2 looks like. If you have, let's say, snake with length 6, this is how it looks like. See? When I move left, up, down, etc. Now that my snake is kind of ready, I want to now draw apple. So for apple, so the purpose of the game is snake is eating an apple. Apple goes at random position, and as snake eats apple, the length of the snake will increase. If you're not sure about this, I have all the source code in the video description below. So just take the final version of the source code and try to run and play the game so you get an idea. So here, now I need to create an apple class. So see, in object-oriented programming, whatever objects you have, you create classes for those objects. So we have snake, we have apple. So we created classes for both of it. Now apple is also an image. So if you look at this image, this is also 40 by 40 pixel image. So I need to load that image first, right? And we have already seen how you load the image. Like the same code, I just copy pasted here. And Apple also needs a parent screen here. See how you have a parent screen. I'm just going to change this. We need a parent screen so that Apple can be painted on that parent screen. Okay. And what else do we need? Yeah, X and Y. Because Apple has a position, right? And this position will also be in the multiple of 40. So I'm gonna keep it 120. So like 120 by 120. See, if I put it 20, then snake and apple will not align. It has to be multiple of 40. So just to make it generic, you can do something like this also. And of course, you need a draw function to draw the apple. And how does draw work? Well, it will be, okay, just copy paste this code. So there is no for loop, of course. So here, instead of solve self dot, I'm just saying self dot image, and X and Y I'm painting here. I probably don't need fill here because fill I will do it in a snake draw function. Okay. All right. So now I have my apple here. Now apple I need to initialize in my game class. Okay. How I initialize snake. So I will just say this is my apple, and the parent screen you need to pass, and then you need to say draw. Now when you are running this event loop, see here you are saying self.snake.walk. So here also you need to draw your apple. Otherwise what happens is in the walk function, you are in a draw function, you're clearing the screen. So it will clear the apple. So that's why we need to do this. So see, I see the apple now, which is good. Okay. Now one thing I noticed was right now I have two objects. If you have like 4, 5, 10 objects, and you have to keep on saying self.object.draw. So just to modularize my code, I will write a method called play in my game class. And this method play will have those two methods. In the end, it's working the same, but at least code wise, when you read it, it's like in your for loop, okay, in your while loop, play, and play is doing all the drawing. Okay. So far, we are moving our snack, and there is an apple, but there is no actual game logic, which is if snake eats the apple, it should increase the length, and then apple should move to a different position. So in this video, we are going to implement that logic. Now, collision detection is a very common thing in any video game. So we are going to implement that concept. So first, we will write a function in our game. Okay, so what do we want to do? Just think about it. When snake's head hits the apple, we want to increase the score. So how do you detect that? So just think about it. So let me open paint and kind of go over that a little bit. So let's say this is your application screen, and let's say this is your snake. This is your snake, right? So it's just like a couple of blocks. I'm just going to make it bigger, and it is just a list of blocks, nothing else, right? Okay, so let's say this is my snake, and let's say this is my apple. Now the apple also has a bounding box. So apple is actually a circle. It's an icon that you're showing. So it will be like this. And when you hit that apple, what's happening is, let's say this snake comes here. For example, this guy here, let's say comes into this area. Let's say this is collision, right? So here what happened is actually the y, the x of both of these are same. The snake is moving up, but what has changed is the y. So just think about y. So this is your y, correct? Y1, let's say this is for apple, and this is your y2 for your head of the snake, right? So this is the axis that I'm referring to, and for y1, this is the point that we're referring to. Now what happens is, when they collide, see, y1 plus size is what? So y1 plus size will be this much. See, y1 plus size is basically this much. Size is the height of the apple. So now what happens is y2 is in that boundary. It is in y1 plus size. So if you do, let's say y1 plus size, this y2 now is in that boundary. You got it? So my y2 is now less than y1 plus size. So this is how you can detect the vertical collision. Same thing with x. Okay, so we are going to implement that method as per that logic which I just explained. So in the collision, always you're trying to decide if two rectangles are colliding. So then you will always have x1 y1, x2 y2. Okay, and if x1 is less than equal to x1 plus size, see, the width and height of both apple as well as the snake block is 40. So that's what we have initialized, size to be 40. So x1 is less than that, and actually x1 is so the logic will be x1 is greater than equal to x2. Let's think about y first. Okay, so y here, your y2 is less than y1 plus size. Okay, so similar logic you can apply for x1 as well. So x1 is greater than equal to x2, and x1 is less than equal to x2 plus size. And the same logic applies for y1. And I'll go to the diagram and explain you in a bit. But if the same logic for y, if both of these conditions are true, then you return true saying that there is a collision. This means there is a collision. Otherwise there is not a collision. Okay, so let's understand this. Y1 greater than equal to Y2 and Y1 less than equal to Y2 plus size. Okay, so here, this is being my Y1. So let me just here in my code at least see, I have this as Y2 and this as Y1. So what's happening is, see, let's look at this logic here. So that logic will go here. This is the logic we have, right? What this means is, let me just put it in a bigger window. What this means is my y1 is less than y2 plus size. So you already saw this y1, okay, is less than y2 plus size, okay, and your y1 is greater than equal to y2. So y1 is greater than equal to y2. Okay, so you can just debug the code and kind of figure out what it means. Here actually, hold on, y1 is greater than equal to y1 is actually less than. So I think previously what I was doing is correct, which is, see, it can be either way. Like, so I think this is y1 and this is y2. Okay, this is y2 and this is y1 plus size. So if you look at this, let's say if you think about this as a y-axis, so y-axis starts from 0 first, right? So it will be 0 here, then it will be whatever, like maybe 5 here and 20 and so on. So it is increasing in this direction. So if you think from that perspective, the y1 is greater than equal to y2, right? So this condition is met, and y1 is less than equal to y2 plus size. So if you have y2 here and if you do y2 plus size, which is 40, so this block, so y2 plus size, so y2 plus size is this much, right? So y1 is less than that. That's why this collision logic works. So just debug it, you figure it out. This is a simple logic. Now when snake hits the apple, you want to increase the length. Okay, so here in the play section, if self dot is collision, okay, and you want to check the impact with only snake's head actually, because you don't need to check it with the body. So snake's head is the position 0, and then you will say this apple dot y. So you're checking the coordinate of apple and snake's head, which is at element number 0. And if you find a collision, you will say this print collision occurred. Right now, let's do this much, just to make sure things are working okay. And after that, let's see if we have anything pending. So you are doing collision. Okay, let's run it. So you see this collision occurred message, right? So that means the collision happened, and now we can, whenever collision happens, what we want to do is we want to move the apple to a different position, different random position. So let's write the code for that. So we'll say apple dot move. So this means once snake apple hits the apple, we move apple to a random position, and for that you can come to this class here, apple, and write this method called move. So here you will move this to a random position. Okay, Now, how do you do that? So there is a module called random, which you can import here. And I'll show you. See, if you do idle, um, I'll just quickly show you how random works. So random has this function called randint. So if you give, let's say, 1 and 10, it will give you a random number between 1 and 10. See, every time you run, it gives number between 1 and 10. Now our window is 1000 by 800, correct? And apple size is 40. So if you do little calculation, 1000, okay, divided by 40, you get like 25 increments. And if you do 800 divided by 40, you get 20. So you get like this horizontally 25 increment of 40 and vertically 20 increment of 40. So what I can do is, here I can say random.randint, okay, give me a number between 0 and 25. So horizontally I have 25 increment into size. So what will happen here is, if you look at idle, let's say between, like 1 and 25, I'll just do 1 because, or 0 is also fine. And size is 40. So see, every time it gives me a number which is always gonna be less than 1000. So we don't go out of our window boundary, and the number will be divided by 40. It will be a multiple of 40. And I did the same thing with y. So for y with 800 height, you can get 20 increments, okay? So you, after the collision, you move it. So let's run this. See, after I'm colliding, so my collision detection is happening perfectly, okay? And the snake is moving. Okay, now on collision, you want to increase the size of the snake. So that will be a score. So in the initial phase, I'll start with the snake size of 10, 2, or maybe 1. And then I just keep on incrementing the length. Okay, so on collision, you want to increment the length. So here, okay, where is my collision? Yeah, here you want to say length you want to increment, right? But you have to do something else as well, which is when you increment your length, see, you need to add one more block in this x and y, because x and y is an array. It is holding the position of the new block. So for that reason, I will just write a new method here called increase length. Okay, where you first, of course, you first increase the length, but then you want to add something into x and y. So this is how you add a new element into an array. And I'm adding -1 as a value. You can always tackle this in your walk function. In your walk function, we'll put a right coordinates of x and y. That's why we can just start with some random value here. So here I will say increase length, and let's run this. See, now after it hit it, the size of snake is 2. Now see, it is 2, and if I hit it again, it will become 3. You will watch it. See, now it became 4. 5 and so on. Okay. I think I noticed something weird. See, if it moves even near, say I'm not going through apple, if I go even above apple, this is fine. If I'm going even from near apple, it is increasing the weight. And I think that's because of this less than equal. I think this should be probably less than. Okay. See, now it's working as expected. So now it increased the length and so on. So here also Apple moved to a very far position. So I want to restrict it. So I'll just say 40. This is 90. On 0, 0 position is probably okay. All right. So this is looking pretty good. So now next thing I want to do is display the score. Okay. So in my game function, I will write a method called display score. And this should just display the score at the maybe top right. I will choose top right to display for displaying the score. And Pygame has this font module. So I'm using the system font, which is Arial, with a 30 font size. You can increase it as well. And then this font I will store into a variable called score. So this is how you do it. And here the score is nothing but the snake's length. Okay. So I'm using Python format string, storing like score there. And in render function, this is your color. So if you do like 255, 255, 255, it will be white color. So you can choose whatever color you like. And then, we always have a surface. So whenever you want to show anything on a surface, you have to use billet function. And then what are the coordinates? Well, let's say 810. So that will be top right corner. And once you do that, here I can display the score. And after displaying score, of course, you have to do pygame.display.flip. So you see the score at the top here? Okay. So now, see, score increased too. Score is equal to the length of my snakes. 3. Yeah, I'm doing good. Wonderful. My game is coming up so nice, guys. So in last session, we calculated the score by finding out the collision between a snake and an apple. In this session, we will work on a game over logic, which is if the snake is curling around and if it hits its own body, then the game is over. So for that, again, we are going to use this is collision function, right? So here, let me just run it and tell you what exactly I'm trying to do. So here, let's say you have a snake of size 7. When you run it, see, if you get into this situation, you see, like when snake is crossing itself, then we want to exit the game. So this was a logic of snake colliding with apple. Now we are writing a logic of snake colliding with itself. And for that, snake has a number of blocks, right? So you can just do for I in range 0 to self dot length. Now, what type of collision you're trying to find? Well, you want to find out if the head of the snake, which is x0, collides with itself or not. So if you look at whatever this diagram that we have, let me just clean it all. So here, let's say this is my snake. Okay. And let's say it's moving, moving, moving. And it makes a turn like this. And it makes a turn like this. And then it again goes here, then that's collision. So then that's when you should die. So this guy is the head. So you want to find a collision of head with remaining blocks. So you will say if self dot is collision, okay, collision of what? Self dot snake dot x of 0, self dot snake of y0, because x0 and y0 is ahead, with remaining blocks. So x of I and y of I. Now since we are finding a collision with x0, we can start with 1. Okay, now let's think about it. Even we can optimize little later. So this head of the snake will never collide with the next part. You agree? No matter what happens, it will never ever collide with this. And I think same thing will happen with the third block. Can it collide with third block? No. So 0, 1, 2. So maybe we can start with 3 directly. So here we can start with 3. And if there is a collision, for now, let's say you want to exit the game. So you will say game over and exit it. Okay. Okay, I don't know what happened. It went out of the boundary. See, when it hit itself, it is exiting with that game over message. So logic wise is working fine, but what I want to do is when that thing happens, I want to show a nice message saying that the game is over, and also if they want to replay, then we should give them some option of replaying. Let's say if game is over, if they hit enter, then we want to give them that option. Okay, so first of all, I'll remove this, and instead of that I will raise an exception. See, exception means, so raising exception means something unusual happen and we want to go out of the game, and you're throwing an exception, and here you have to catch that exception, and this is how you do it. If you don't know about this, again follow my basic Python videos and you will get an idea on this exception. And here, all right, what do you want to do here? I want to maybe show a game over message. Okay, and that game over message, let's see, what do we want to do? So in the game over message here, show game over. Here in this method, I want to display a nice text in the middle saying that okay, game is over. And for that, first you need to clear the surface, right? Because whatever you want to wipe out, you just show a message. So here for fill, which color did we use? Well, we use this. I'm going to store this in a variable called background color. Okay, so background color is equal to this, and I will see, whenever in programming language, when you're using something more than one time, it's better you create a variable. Okay, and once the screen is wiped out, now you can render your text. So for that, we'll use this thing like font. We already show the score, so we can use the same thing here. And okay, so I'll say line 1 font dot render something. So what is our score? So we want to show the score to a user, and then we want to exit the game. So you see score, this one. So I'm just copy pasting the same thing, and I'm showing it in white color. You can change this color. This is RGB. And self dot surface dot grid. And anytime you want to show anything on a surface, this is what you call. and I am showing in X and Y is 200, 200, 300, which is in the middle of the screen. I want to also show another message saying that to play the game again, you can hit enter maybe. And I will just show line 2 and 350 maybe. Okay. So show game over. Let's see what happens. Okay, something is not right. So show game over is here. Okay. So let's run it again. So I realized this was happening because I did not have flip in the show game over. So whenever you are making any UI changes, you have to call pygame.display.flip. So UI is this is like refreshing your UI. So now see, so game over message is showing up, but then it's again restarting the message, restarting the game. And why is that happening? Well, that is happening because just think about it. You show this message, okay? After that, you wait 0.2 second. You're again going into this loop. See, again processing all those keystrokes. So we have to implement a pause mechanism here. So we'll say, okay, pause is false. And when the game is over, pause becomes true. And when the game is paused, by the way, I don't want to process all of this, right? So game is paused here. Yeah, if the game is paused, I don't want to process even left, right, all these keystrokes. Or yeah, this one. If not paused, I don't want to play the game if it is paused, correct? So this is something you don't want to do. Also, okay, let's run just this and see what happens. The game is over. Now I hit anything and it's not restarting. So we said to play again, press enter. So if you press enter, you want to unpause it. So how do you do that? Well, here you can say if event dot key is equal to key. Enter is basically return, and here you will say pause is true. Okay. So pause is false actually. So here, okay, game exited. Okay, I'm pressing keys, nothing is happening. And when I hit enter, see game started again. Also, just to make it safe, you don't want to process even left, right keys. If the game is paused, just pause, guys. You don't want to do anything. So don't process all these keystrokes if the game is paused. Simple enough. All right. Now let's see what's remaining. So after the game is paused, see my score is right now, let's say 8, 9 score. And game exits, my score is 9. If I hit escape, I go out, but I want to play this game again. So when I hit enter, see it is starting with score 9 again. So that is bad because you're not resetting the game. So here you need to reset the game. So you will call self.reset method, and reset method is something you will implement here. So you will say reset. Okay, how do you reset the game? Well, whatever snake and apple you have, you just reinitialize those two. And I'll initialize it with 1. Okay, so when the I have scored 7 and when the game is over, when I hit enter, see I start fresh with score 1. Okay, so I think you get an idea. And by the way, I don't want to start with like score 7 in the beginning as well. So here also I do one. So that way, you always start with one block, then it increases. Oh, my apple moved out. See, my apple is moving out. Where is it? Yeah, this is happening because we need to reduce this limit maybe. Yeah, because it's probably moving too far. So that's why I'm reducing the limit, and I hope it works now. Yeah. So far, our project is working fine. It is functionally correct, but doesn't look very fancy because it doesn't have any music. The background is dull. So in this session, we are going to add background music as well as the background texture to this game. For this, what we'll do is whenever Snake is eating an apple, we'll play some music like ding or something. When the snake collides with itself, we'll play another music, and then in the background also we'll keep on playing some music. So first, let's take a snake eating apple scenario. So you need a short music clip first of all. So for that, I did some Google, found this nice website, Free Sounds Library, which has this ding sound. So see, if you play this ding sound, see, chin. So we'll play that when snake eat apple. So in the resources directory, I downloaded that file. So see ding.mp3, and for collision crash. So when it snake collides with, so we'll play this music, okay? Now when you do Google on Pygame play sound, you will find this class in Pygame called mixture, which has a sound element to it. Okay, so we'll be using Pygame mixture for playing music, and in that you first need to do pygame.mixture.init. So let's do that. It will initialize the mixture module. So let me just first go into my meditative Zen mode. All right, so no distraction now. You go away, buddy. All right, so here in the init, I will say pygame.mixture.init. So my sound module is initialized. Now, when I have a collision, or let's say, yeah, when a snake eat apple, I want to play the music. So how do you play that? So you will just say simply pygame.mixture.sound, okay? And in the sound, you will use resources. We'll use ding music, and let's store this in a variable called sound. And then you can just say pygame.mixture.sound.play. So that plays the sound. So I'll right click, run it. See, when snake hits apple, it will play the music. See, listen carefully. See, ting. Okay, and when it collides, you'll be playing the crash music. So here, I'll just say crash. So let's test that as well. So ting guys working okay. See, your game is over, your score is 3. So that sound that you just saw. Now, whenever in your big program, you find that you are repeating the lines of code, it's better to put them in a function. Here, between these two line and these two line, the only difference is this name of the sound. So what I can do is I can put these two into a function called play sound, let's say, you know, and we can supply the name of the sound as well actually. So here, see, here I can do self.play sound, but I need to tell this function that it needs to play ding. So I will just say ding here, which I can get that as an input sound. And here I can maybe convert it to Python format string. And here, if you have sound variable, so whatever you pass here, it will try to load that .mp3 file. So here in this case, it will be crash. Okay. And now tomorrow, if you want to play 10 more sounds, you just call that function with the name of the file. If you don't want to use name of the file, then you can just check here, like if sound is equal to ding, then that's your file. Okay. All right. So you can run it. It will work okay. Now I want to play background music as well. While the game is being played, you want to hear nice music. So I have downloaded this background music from YouTube audio library. So that music I will play in the background. So again, I will define a function called play background music here. In here, I will be playing that music. So now this time, instead of sound, I will use music. So the difference between the music and sound is that sound is just one time, like ding or crash. Music is like a long music, which you use generally as a background music. And resources, okay. And then pygame dot mixture dot music dot play. So that will play the music. And you want to call this function when the game starts, right there itself, you want to start playing the music. Okay. So see, initially there was 1 or 2 second pause because the game itself, the music itself has a pause. Okay. Now, once this is done, what you want to do is see when the game pauses. For example, when you hit when you hit snake body, okay, you want to stop the music. So let me show you what I mean. Say music is still playing. I want to stop music. And when you restart, then maybe start the music. So when you have game over scenario here, game over right here, during this time, maybe I can call pygame.mixture.music.pause. So it has a nice method called pause. So it will just pause the background music, okay? And you want to resume it when user hits enter. So when this is when you are unpausing it. So here you can say pygame.mixture.music.unpause. Okay. And now it will pause and pause easily. The music stop now. And when you start again, it will restart the music again. Now I want to change the background of our game. So for that, I have downloaded this nice texture. So this looks like a grass field on which snake is moving around. So I will set this as a background in our game. So for this purpose, I will here define a new function called render background. And like image you can load easily by calling pygame.image.load, and here you can load this background image. And if you want to show this image, you know that you have to use this blit function. Okay, so pygame dot actually self, where you specify where you want to draw the image on your surface and X and Y. So we want to render this background from 0, 0 corner all the way, right? Now this background size is actually, you see, 1920 by 1080, and our window size is 1000 by 800. So it will work okay. Now this render background, I will do, where should I call this function? You know what? We are doing this background color. So wherever we are calling this function, you have to replace that with render background. So here self dot, okay, no, this is, wait, so this is different class actually. So here you're drawing it, right? So you're drawing snake. So where do I draw snake here? Here, yes, here. So here I have to say render background because you draw apple and everything. So just before that, you have to render the background. Okay, where else did we use? Oh, show game over. So here also self dot render background. So now see, nice background, it looks pretty good. So you can play with the background, the Apple image, the score fonts, and make your game a little more fancy. The code for this entire project is available here. I have Python projects directory where I will be uploading more Python projects. So please keep an eye. Right now it's just one project, Snake Game. And if you go to that project by clicking here, by the way, my next project is gonna be document text extraction using OCR, and there'll be different projects that I'll be covering. But for this project, I have an exercise for you. So if you scroll down, the exercise is whenever snake hits the left or right or bottom boundary or top boundary, you want to exit the game. Okay, so game should remain in the field. If it goes out of the field, then game is over. So you need to add that logic. Second thing you need to do is increase the game speed. In the game, whenever you go to next level, the difficulty level increases. So that's what you're trying to do here. Once you develop your own solution, then you can click on my solution by clicking on this link. But please try to work on your own first before you click on this solution. Now that your game is ready, you want to convert Python file into exe file. Exe file is an executable file which you might have used it for different programs. So this is something you can give it to your friends and your friend can just use that exe and run the game. So this completes the whole game development cycle. When I Google convert Python to exe, I found this nice module on PyPy. So just do pip install this particular module on your computer to install it. So if you do this, it will just install that particular module. And once it is installed, you can run this command on your command prompt. And it will open a nice user interface where you specify your file that you want to convert into exe. So this is the final file path. So I supply that. Second option is either you want to create the whole directory or just one executable file. Now you would probably prefer this because it just creates one exe file. So you can do that, but right now I'm having some Python 3.8 incompatibility issue. So for me, it is not working as of today, but you just try it. It might work for you. So I will just go with one directory. In the additional files, I want to specify add folder because I want to specify all the resources. The resources has background music and everything. If you don't do this, it will not work. So this is a very important step. And then you can just click on this command, say convert that to exe. So internally, this tool is taking your Python file and generating the binary or the .exe file for you. I selected the directory options, so it will create a big directory, but if you choose one file option, it will create just one file for you. Once this is done, click on open output folder because that's where your exe file is. So, okay, since I created directory, it has created the whole directory here. Okay, see, this is what I got. And if you click on this exe now, see my game is playing. This is my game, guys. Now you can right click this and you can say send to desktop. And when you do that, it will create a shortcut on desktop. So let me show you. So it created this shortcut. And now see, whenever I log into computer, I want to play the game. I double click. So it's like just any other program. You see? So now you can take this folder, zip it, or there is an option to convert it into installer as well. You can convert it to installer and um, give it to your friends, and you can be now proud about yourself because you built the complete game. You can use these learnings that you did in all these videos and maybe make a different game. Maybe you can make tic-tac-toe or different type of games. So now you are capable of building full-fledged game in Python. So I hope you like this series. If you did, please share this project with your friends. I have complete source code available here along with exercise, the solution, everything. So all you need is a laptop and internet and a little bit willpower to learn this thing. These things are super easy. This project is perfect for even kids. You know, if you are in 5th grade, 4th grade, you learn a little bit Python from my videos and then you do this and you will be able to build cool games. So I hope you liked all these videos and thank you very much for watching.